masks are for, right? Oh, you guys, guess what my husband brought home? The new Xbox. You should have seen my kids' faces. My daughter was like, is that a new speaker? And then she's looking at it and she's like, ah! And my son, who I thought would have the best reaction, was just so dumbfounded that it wasn't even that good of a reaction, because he was just like, what? Really? Well, if you get it, like if you buy one of the pirated, like, because what's happening is that they're in there's such a demand for them that pirates are, I guess I call them pirates, but I guess they're not technically pirates, but they go and they buy them all and then they sell them on eBay for very expensive. So they're trying to get a buck. But I think he got it from Best Buy, but Best Buy had this thing where you actually had to come in person to pick it up, which is why he was able to get one. Yeah. But it's cool. I mean, I guess. I'm not super into video games, but my family thought it was very cool. Forgot a letter, sorry. Is that right? I'm losing my mind a little bit, you guys. Yeah. Okay, so I love pattern problems. We're going to look specifically at toothpick problems today. They're called toothpick problems because we use like we make shapes out of like little lines and stuff. Okay, so let's look at an example. So we're going to assume that each one of these lines is a toothpick. Okay, so let's talk strategy. Okay, the first strategy I would put into place is counting out how many toothpicks are in each step. Okay, so I would go to step 1 and I could see that there are 3 toothpicks that make up that pattern. Then I would go to step 2. I would count these up, and I would see that this is 5 toothpicks. Then I would come over here and count these up, and I would say that this is 7 toothpicks. Now, another strategy tool that you're going to want to incorporate is you have to go back to step 0 to figure out what the initial number of toothpicks was. Because when you get to step 1, you're already adding on toothpicks at that point, okay? So one way to do that is just to do like a little T-chart. So we'll do the step number, we'll use the variable n for number. So step number n. And we'll say that this is the number of toothpicks. Okay. So I'm going to always leave that 0 spot there because that's going to help us to find out what we start with. Okay. So we know that step 1 was 3. Step 2 was 5. Step 3 was 7. So what would step 0 be?
1.
Awesome. Okay, and then if we were to keep going, this would be 9. So this right here is your like initial value or what you start with. And then what you're adding each time is your rate. So this right here would be considered your rate. So then when you're writing an expression for this, it's going to fall always in that same way. You're going to have some number times your variable n plus some amount. Okay? Well, this is always your rate here. And this is always either an initial fee or what you start with. So in this case, our rate is 2, and we start at 1. Everybody agree? Good? So let's do another example, and then we'll summarize our strategies, okay? Okay, there's our toothpick. Okay, strategy 1. Count how many toothpicks are in each one. Okay, then we're going to create a table so that we can find out what our starting value is. Which is something odd this time, right? What would be the starting value? Bea, go ahead. Yeah. How do you draw that? I don't know. But we just assume that this pattern is going to continue on the same way that it always has in both directions. So yeah, I would say -2. And then this one would be 10. All right, so what's your rate? 3, good. And what's your initial value? -2. So then when you write your expression, it's going to be 3n minus 2. And this one was 2n plus 1. Okay. Okay, I'm going to have you try a few patterns too. All right, see if you can write an expression to represent that pattern, and I'll put another one below too. You gotta see which patterns I've used. Let's do a third one too. It's an octagon, by the way, in case you can't tell from my sloppy toothpicks. I have 3 patterns up there for you to write expressions for. I'm gonna walk around and check on everybody. look at these real quick. So I'm going to count up 4, 6, 8. Okay, which means that if I was going to go backwards, step 0 would be 2, right? So did you guys get 2n plus 2? Yes, awesome. Okay, next one. This one was straightforward, but it was so straightforward that I wanted to make sure you're good on it. What would step 0 be? 0. Okay, so then when you put it in this form, this is going to be 0, and you're just adding 1 each time. So this expression is literally just n. Whatever step you're on, that's how many toothpicks there are. Does that make sense? Yeah. Did you guys get that, or did you like leave 1 with it and add 0 and all that stuff? You had 1 n? Yeah. Yeah. All right, so let's take a look at this next one. This is 8. This is 13, I think, right? And then this one would be 18. So you're adding 5 each time. So what's the initial one? 3. Okay, so then this would be 5n plus 3. You guys agree? And a surefire way to make sure that you're accurate is just plug in one of the step numbers and try it out. So if I plug in 3 here, 5 times 3 is 15. 15 plus 3 is 18. So I know that my expression works if it works for all the steps. Okay? So let's go ahead and file this away. Okay, so next week we're going to work on equivalent expressions, and we're going to review everything, and we're going to take our expressions up a notch to get ones that are much longer, more on the lines of these ones right here. Okay, so that you're getting lots, you're going to be incorporating all of your knowledge about expressions to then simplify it. Okay.